Hello, this is Darren Pulsipher, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, the benefits of graph databases with Hadi Ahmadi, Director of Product Solutions at Katana Graph. Hadi, welcome to the show.
Thank you so much, Darren, for inviting me and giving me this opportunity to be able to talk about this interesting topic.
Well, it's really interesting because when I first talked to you guys about graph databases, I was like, yeah, I know a little bit about graph databases. Then you blew my head off because you taught me a whole lot more on what you can do. But before we get into that, Hattie, tell my audience a little bit about yourself.
Sure thing. Absolutely. So let me actually start from a little bit of my background and where I came from. I got my PhD in computer science in 2012, did a lot of research in cryptography, network information security, and were in academia for a couple of years after, then moved to industry and focused on different aspects of security solutions, from identity and access management to other things. But I think it was since 2015 or so that I started to learn more about graph data modeling, graph databases, graph data structure. And it was interesting enough for me to actually start thinking how we could model some of these complex problems in my field of study and see whether we can benefit from a graph data modeling and how we can possibly better solve them. And that was interesting enough actually for me to be able to actually do this kind of things. And the results were very promising. I had a lot of projects worked on. And that actually made me decide, I want to dedicate more of my time to graph. And that's why I joined Katana Graph. And I'm now there as a Director of Solutions Architecture, also work on the product, very happy to do so, and trying to actually be finding those interesting problems that are complex enough that the existing or alternative solutions cannot tackle, and hence the graph.
So this is really interesting because you guys are trying to, in some respects, displace a technology that's been around 70 years, which is relational databases, right? Those have been around since the dawn of data structures and things like that, right?
Exactly. Well, let me first. I know that most of people that are probably listening to our conversation already know about this concept of the graph and the graph data structure. But to respect everybody who might be interested in the podcast, let me tell you first. What do we mean when we talk graph or when we say graph?
Okay, that sounds great.
First of all, we're not really talking about graphs as charts or the graphical interfaces or things like that. Not even for that matter a graph in a way of visualizing data using nodes and edges. That could be a side benefit or side product, but we're really talking about a way to structure your data in storage level so that you can retrieve and process this data for some of the complex problems, especially if this data is interconnected. On that note, I should say that it's not that graph is going to do the magic and solve all the problems. And we're not here, at least that's my belief, that to replace or even compete with the existing data structures or solutions. Is probably complementing those for some of the problems that they can't tackle. Still, if you look at some of the problems, some of the data, hopefully we can talk about that. The nature of the data would be in a way that you could still benefit from a key value data store or relational database model or object storage for that matter. So it doesn't mean that graphs are there to solve all the problems. You really need to look at your data and see whether you can benefit from graph or not.
Okay, so that brings up an interesting point because graph databases are great for linkages and relationships, right?
Yeah.
But isn't that a relational database? I mean, a relational database is all about relationships.
It has it in a term, right?
It has it in its term. So what's the key differential here? I know relational databases, I've got a table, I've got, I can relate from one table to another table. So what's the key differentiator here?
Fair enough. It's very valid, very good question. I'm glad that you asked it. Yeah, you're right. And relational databases are all also about respecting relationships. The main difference is that in relational databases, we actually put this relationship in the metadata level, in the schema level. Whereas in graph databases, it's going to be data-driven relationships. So relationships are going to be part of the data versus part of the metadata in relational side. So in other words, in relational databases, we are relating tables, columns of the tables, basically. And if you want to introduce a new relationship, basically you need to change your schema in a way. Whereas graph provides this quote-unquote schema-less infrastructure for you to be able to actually add a little bit of more structure around your data, but still be flexible, so you can ingest any sort of unstructured data as well.
Okay, so it's great at unstructured data coming in, schemaless, which means great for data I don't quite know what the schema is yet, right? So I can see those benefits. But isn't everything already stored in a database?
It is. No, absolutely. It's just the fact that, again, the main risk that we're now facing is big computation. So we have had conversations around big data for a long while, and that thanks to a lot of technology, basically that has been built and provided within the last few years, we have been able to collect a lot of data from different sources. So more than half of the world's data has been created within the last couple of years, but only
That's amazing.
less than 2% of it has been analyzed, which means that, again, thanks to those data lake sort of experiences, you can excellently collect data. However, when it gets to processing that data, there's not enough you can do. So you want to have a way to flexibly add a little bit of a structure to this data, not really much, and it's dynamic enough that you can easily change it if you're uncertain, but still benefit from optimized advanced computation on it. And Graph is an excellent way to do so.
So with only 2% of the data being analyzed, most of that data analyzed is structured data today, right?
Yeah.
But what percentage is that unstructured data that's sitting out there of all this new data being generated?
It's a very valid question, a very good question. I don't really know the exact, basically fraction of that data, but I assume that all of that unstructured data now is being tackled using low-level APIs of the data lake experience, which works excellent. But the problem is it lacks the optimization, because if you deal with unstructured low-level data, you can't really do any sort of engine optimization to the computation.
Okay, so how does Graph Database help with that unstructured data, or give us some examples?
Yeah, no, fair enough. So as I said before, again, let me start with this. Again, I would love to just make sure that I stay fair with this concept that, hey,
Okay.
if you do have a data that, or a problem deals with data that's isolated. I mean, you have a bunch of key values, documents you want to store and retrieve. You don't really need Graph. If your use case is all about storing data, blobs of storage, you could use an object storage. You don't need Graph. But if you're actually trying to work with correlated data, interconnected data, that's where you would benefit from Graph because of the relationships. And this comes almost in any industry, because the unstructured data usually comes from a variety of sources and variety of natures. And when I can give an example that I may be more versed on, as let's say we want to go and do cyber security solutions, looking at the logs and audit trails that come from the network environments, the cloud infrastructure, the endpoint hosts, and all that. And these are all coming from different sources. Data is different. Some of them are coming from directories, some from raw log files, and so on and so forth. And we would like to have a way to be able to correlate the data, because typically, an identity or a user that could be part of a log that comes from our identity management system could be the same user that triggers a process in a laptop, or maybe downloads an attachment from an email. and da 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 da. So if you can actually use the correlation or linkage between this data, you can get more insight from it by just analyzing those patterns. So this is what I'm trying to say. Like, it doesn't matter how or where your data is coming from, by providing that sort of linkage between these data points, you'll be able to learn more about each and every record by looking at the context around it.
So I like the context part of this, because that's where I can really start looking at real data analytics. Where did my data come from? What else is it related to? I love the example of an email, because I can't imagine building a relational database that shows an email. I mean, that would be really hard. Because I've got attachments to it. I've got responses. My data tables would be massive, and there would be so many of them to show all the different relationships.
Yeah.
So with graph databases, I can form these relationships dynamically as my data structures are dynamic. Is that right?
Absolutely. And maybe even to make it more sort of bold, is, if you have a problem anywhere and you think you can just go to a whiteboard and just model your data with, just some whiteboard friendly sort of nodes that are connected with edges, then it seems that you can benefit from a graph that you don't want to downgrade that model you have in mind to tackle, but just, make it a two-dimensional data structure with, tables with rows and columns. You would actually be able to store it as is, and I emphasize as is, in a graph data structure. So why not do so?
Yeah, no, I like that. I like that a lot. So I can see one of the benefits. One is I don't have data transformation issues, so that's going to speed up things dramatically, right? Because I'm not trying to represent complex relationships in several tables, so I'm decreasing also the storage requirements, right?
That is correct. That is correct. I mean, it would be one of those, double-edged swords that, depending on how you model data. But you're right that, let me just maybe talk about this social network, because that's very easy.
Social network. That's a great one. Yeah.
So to me, if you want to make it very simplistic, the graphs and relational databases or relational data structure in general are very compatible. The node types look like the tables. So I have a node type called, like, let's say, person, and then I could have a table called person in my relational database. Great.
Right.
I might have another node type called location and connect my person to a specific location. Of course, I can have a table called location and connect them through foreign keys. Awesome. Now, I have this relationship of friendship, right? A person is friend of person. In my graph model, it's just a self-loop kind of thing, right? That would allow me to just model that schema if I want to. In a relational database, I need to create this new table called friends, and then I need to connect it. So even at the schema level, I'm adding some redundancy and some structure over top of it. And if I need to add a new concept of friendship or relationship, I need to create new tables yet. So that is the redundancy or complexity, the way I see it.
So you're right, and it does add a lot of complexity on traversing tables to get information, on maintenance, management, building indices. All that stuff now becomes more complex the more relationship tables that I have. So I really kind of like this a lot, in that what other benefits do I get from a graph database over relational?
Yeah, the one other thing about graph databases is this whole area of graph analytics and the graph AI. I'm not going to go into details of those things. Basically, the idea of being able to now model your data and being able to find patterns on your data based on the way that data is connected is great. An example could be PageRank algorithm, which is put forth by Google to be able to actually now sort the pages that have been searched over time. What is the most linkages to the page and all that. So once you have a data modeled as a graph, then you can simply run a PageRank algorithm across the graph and find a rank for each and every node based on how they are connected to the others. The other example could be finding the components. So you have this big data. You have a problem to solve. You don't know how to tackle this in a relational database. But if your data was in a graph, the one thing that you could do possibly, if it again made sense depending on your problem, would be to divide and conquer, to use a connected component sort of algorithm or some sort of community detection algorithm on the graph to be able to chunk your graph to subgraphs that are of focus. And then you could go and look at a specific subgraph of certain size and be able to solve your problem on that specific subgraph. That's another way of looking at it.
So help me understand. So what I think I heard was I can decrease the data set that I am searching through or analyzing because of the relationships. I can prune things down to a more substantial set.
Correct.
Instead of searching everything.
Exactly. It's
like that's interesting.
Using the power of data to even empower data even further. This connected components or things like that would be even looked at as ways of doing feature engineering for our ML AI layer where we can take advantage of it. And this information may not be explicitly given by a relational or any sort of data, but it can be found using some sort of graph mining, data mining of your data.
Gotcha. So the algorithms in a graph database are very different than the algorithms that we've seen in relational databases. And better optimized, you think? Or I can get to large sets of data faster.
Absolutely. I mean, better optimized for those, again, for the purpose that they do. I mean, if you're talking about graph algorithm, which is about depth first search, you need a graph data structure. If you want to use a relational data or anything else, that would be killed already.
Let's say that I just had one big table and I'm just doing raw searches for, I need everyone with this zip code. A relational database would probably be the way to go.
Absolutely. I mean, if those are the queries that you want to get, that would be it. But if you're in the realm of, let's say, managed master data management or some sort of entity 360, entity resolution, those kind of things that actually would benefit from modeling your data in a way that you can actually find those paths or patterns between different entities, then relational database can't help you in a scalable way. And again, I'm saying that
in a scalable way,
you can definitely model anything that today we have in a graph database with a relational data structure and vice versa. It's all about when data scales, one of them can't keep up.
Gotcha. So let's talk about scale a little bit. When you say scale, I mean, how big are we talking? I mean, in relational databases, we talk about number of rows, right? That would be comparable to number of nodes in a graph database, correct?
Pretty much, yes. You're right. Number of nodes for that give you actually number of rows times number of tables in a relational database.
Right.
Plus, you do have the relationships here as well that would add to the complexity, of course.
So, how big can these graphs get?
That's also a very great question because, again, the way that graphs work, or actually graph data is structured, it makes it a bit hard to scale and shard. A relational database, it's easy to cut a table and put it onto two servers, right? And that would allow you to be able to more, I would say, intuitively partition your data and go with your scalability beyond a specific one server. So easily go with much bigger data, and that has been one of the drawbacks of the graph data or earlier graph database technologies, that they were all actually designed or built to be a single host solution. So you have a bigger graph. If you want to have a bigger, make it even bigger, you need to scale up, add more memory or more CPU to it.
Yeah, we like it when they add more CPUs and maybe some persistent memory from Intel. That'd be great, right?
It's just awesome, and that's great.
But I can't scale to petabyte, right?
Right. Now, if you do have that, you could definitely you want to vertically scale as much as possible, thanks to the technologies like Intel PMM and all that. But then once you get to basically a place that you want to actually work with petabytes of data, then you would want to scale horizontally. And the newer technologies on the graph data platforms like ourselves are actually all about distributed computing. And distributed computing is basically allowing us to now shard the graph, basically just look at it, in terms of just using a scissor and cutting the graph in multiple pieces and just make sure that those edges or those linkages are kept or preserved. And then you can split or divide the problem into multiple small pieces and have each graph worker work on a small part of the graph and give you the final solution.
Okay, so this is a new thing, right? Distributed graph databases. Because I like how you mentioned that has been a limitation in the past, right? A graph database can only be as big as the amount of memory you have on your box, basically, which makes them screaming fast, right? If everything's in memory, but now you're saying they do have distributed techniques now. So how big can I make a distributed graph now? Is there any limitation?
Well, from our technology, what I can say, we've proven you could use 256 machines or beyond to be able to actually process your data. So if you multiply it by those int hardware, you can easily get to tens of petabytes of data in memory.
Yeah, tens of petabytes. Yeah, that's a lot of data.
Absolutely.
Right, and all in one graph.
All in one graph, all connected.
That's incredible.
That's absolutely. I mean, because that actually matches some of the existing requirements that we have from Graph that are dealing with, daily collecting logs, data, and being able to analyze it and bring it back to the downstream systems. Usually petabytes of data, especially for the companies that provide SaaS solutions for their customers, and they want to have a cross-customer analytics. It's really a very popular sort of use case.
RDBMS has been around a long time. A lot of tools around backup and restore, on managing indexes and purging parts, cleaning up databases. All this has been around for a long time. What about for graph databases? Do I have the same issues, or is it different because it's stored differently? Because you're storing the model instead of a representation of the model. I mean, what's built up around it, and do I need an ecosystem like I've had to build with relational databases?
Yeah, pretty much similar. Maybe Graph is a little bit more dynamic and might be a little bit more flexible to tackle. But I would say that if you are providing a Graph database management system, you would need to go through the same process, very much like relational database. And thankfully, those have already been resolved. Now, if you want to move to Graph data analytics platform, which is a little bit beyond just the operational databases, you could take advantage of other things like data warehousing capabilities, or data lake capabilities. One of them would be just the storage of the separation of the storage and compute, meaning that especially for those graph processing technologies that are doing everything in memory, you don't really need to rely on storage that is attached to the services. So you can have a totally different storage service. What we use, for example, is object storage. And whenever we want to compute, we opportunistically load whatever we want from the graph to the memory, distributed memory of all these machines, finish the computation, bring the data back in an immutable way to the storage. So in that case, even if you destroy the whole cluster, and that's something that you would see data scientists or the analytics use cases require a lot, you don't lose anything. All your data is already there, warehoused, and you just need to actually be able to run your new workload after.
Gotcha. No, so what you're telling me is all the things that I can find in relational databases, analytics packages, backup and restore, maintenance, all that stuff exists for graph databases too.
Yes.
Is that okay? So I'm not bleeding edge out here where I'm all alone and I have no support. There's lots of there's open source graph databases and there's commercial ones. There's more than just one out there. Right?
Again, we talk about these things, and these are all valid concerns because, as you said, the relational database world or others, these are mature fields, and graph is a bit newer. But one thing is absolutely some of these things are already tackled. One of the other limitations that I should say people mention about graph data and data stores is about the language. Lack of standard language to query graph. And it's on the way to go. Now OpenCipher is a de facto standard way of talking to graph. It's very similar like a SQL, I would say, but definitely more intuitive for graphs. And then we are on the horizon to see a GQL, which is a graph query language, which is going to be a standard one, which is pretty much based on OpenCipher. So soon enough, we're going to see a very standard language to be able to talk to graphs.
Oh, that'll be great, because then I have that portability that I worry about, right, as a practitioner. So SQL statement, has anyone written an SQL to graph?
Oh, interesting. Not know of, but there is graph SQL, graph-like SQL statements, or I should say.
Well, some of them won't make sense.
Yeah, exactly.
Like join. I'm going to join what?
Yeah.
There aren't tables to join.
Yeah,
right?
it should be an easy task. But if you do have the graph, I would say, if you do have the graph capabilities, you want to benefit from them. You don't want to downgrade your interface.
You don't want to downgrade them. Yeah.
But on the service layer, I've seen a lot. I mean, now there's this GraphQL, basically framework that will allow us to connect to any sort of relational NoSQL document or graph database for that matter, and be able to provide an API. And GraphQL actually is doing a good job, and it's based on a graph data backend, but it can work for anything. So that would be probably a very nice way of putting this interface in front of the backend layer.
Oh, this has been insightful. Because this is a big conundrum for a lot of people, especially as our data is exploding, especially unstructured or semi-structured data. Sounds like graph databases is a good way to go, but like you said, not for everything. Yeah. So do you ever see anyone maybe going to a graph database first and then saying, "Hey, I understand the structure well enough. I'm going to drop it into a relational database for index speed and things like that," or how do you see?
I think everybody that, well, this is based on my view, and I'm not saying that I'll give 100% certainty on my view, but based on my, I would say about 8 years being experienced in the field and talking to different stakeholders and customers, people that use graph, they immediately see the benefit. They don't want to drop it. The main reason that they may drop it is because of some of the technologies cannot keep up in terms of scalability, and or maybe they're just expensive. So the work that us and every other graph technology out there is doing is try to make graph more like a very commodity tool that people can use for different things rather than a luxury sort of database.
Gotcha. Yeah, like I'm only targeting it to this problem because it's perfect for a graph. The cost benefits are huge.
Yeah.
So I see where you're going. You want to make it more commonly used. That makes sense to me.
Yeah, and I'm working with companies now who are actually providing graph-based solutions. So everything is graph. Graph-based solutions for identity, for master data management, and all that. And they see the benefits immediately that they can't really downgrade back to relational database. And again, I'm not saying that these are replacing each other. Is that maybe it's still relational database are going to be used for some purposes, but not for the problems that necessarily deal with interconnected data.
No, that makes sense. That makes absolute sense. So this will cover almost any vertical. I can see applications, especially for IoT types of devices, right? So we can see this span all verticals. What would you say are the hottest use case, the hottest verticals right now that you guys are seeing the most traction?
Yeah, definitely. I mean, graph in general started from those, I would say, early invention of graph solutions specific to some product, by companies like LinkedIn and Facebook. They have their own social graphs and all that. More textbook now, a very good example could be in e-commerce, right? The problem of recommendation engine, basically.
Oh, recommendation.
Yeah, I mean, this is huge because just look at it. And again, I try to just imagine my mind. I'm going to a whiteboard and try to actually now abstract this problem. What are we talking about? I'm talking about customers, accounts, purchases, products and services, and other things, right? And as soon as I actually can find this connection between them and how customers do some actions, maybe they review a product, they purchase it, they click on a link, and if I can have this basically graph made based on that behavior of the customers, then I can easily now look at a specific customer that now has signed into my e-commerce website and look what attributes they had, what kind of purchase they have done before, what other customers they're similar to, but just finding these patterns or traversing through the graph from one customer to the other, find all the similarity measures, and then be able to provide the recommendation right away to that customer. So this is something that you couldn't do it with any sort of other data store other than graph. And that's
so it's great. It's great for like real time relationship traversing. I love it,
Yep.
right? Because otherwise, can you imagine the relational database queries on that? You'd be hitting all the tables in your e-commerce,
Yeah.
and the joins would be extraordinary, and it wouldn't be in seconds; it would be in minutes if you were lucky.
Exactly. Especially in this case, you already have a
Interesting.
starting point. It means that look at you have your source, and possibly even maybe you're looking at how to walk from that source and find some destination package.
Yeah.
In relational database, this problem is not really meant to be solved that way. In graph, it's just walking over the graph. Simple.
That's walking the graph, which I really like a lot. Well, hey, Hattie, this has been great. Thank you for coming on the show. I learn a lot every time I talk to you. I learn something new, which I appreciate.
Thank you.
And thank you for coming on the show.
Awesome. Well, thank you so much for, again, inviting me to this podcast, having this conversation. It was lovely having a chat with you. I also learned a lot from your comments and your feedback. And anytime, I'll be happy to help anybody that is interested about this concept and wants to learn more about it.
Great. If you guys want to find out more on how to contact Hattie, take a look at our blog at embracingdigital.org, and we'll have an email address up there. Is that okay,
Absolutely.
Hattie?
My pleasure.
All right, there you go. Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and do something wonderful.